Okay, let's walk through some problems using our new sine definition and see how useful it is. So here we have this circle. Here's the equation for it. And this point right here, -3, 4, is on the circle. And they ask what the radius is, just to get us started. So the radius is the measure from the center out. So it looks like it's 5. You can actually get that from the equation. Remember the formula for a circle, this right here is going to be the radius squared. So 5 squared equals 25. So we know that the radius is 5. Now in the next question, they want you to draw the angle of rotation that would go through this point, showing the initial ray and the terminal ray. So the initial ray would be the one right here along the x-axis, and the terminal ray would be from here through the point. So right here is the angle we're talking about. Now they want us to find the sine ratio of this angle using our new definition, which is y over r. So if it helps, we can go ahead and draw the triangle in here. Okay, r is going to be this length here. Y is going to be this length here. And so the sine ratio is y over r. So we've been saying that the sine ratio is the opposite over the hypotenuse, but we've been using this angle. All we're doing now is we're saying we can use this angle. We just have to say, instead of opposite and hypotenuse, we're going to say the y value of this point where it intersects the circle and the radius of the circle. So the radius of the circle we already figured out is 5. And the y value, we can tell from the point that it's 4. You can also just count it. So the y value is 4. So the sine ratio is going to be 4 over 5, which is the same result we would have got if we used our right triangle trigonometry from last year that we've been doing up to this point. But you can see how this ratio, not only is it giving us the same result, but it makes more sense because now instead of using this angle here as my angle measurement, I can use this angle measurement here. This question asks us what the measure of this angle is, and that's kind of hard to tell, but it looks like it's about, I don't know, 120 maybe. So I actually do know that it is exactly 126.869897, and it keeps going. The way I got that is my tangent ratio should be 4 and 3. So normally we'd say the tangent of whatever that angle is equals 4 over 3. That doesn't really help me to find that angle, but what we have here is we have these inverse functions. What they do is they switch the places here. So the ratio goes in here and the angle goes out there. So let me show you what I mean. We would type in tangent inverse of 4/3 and would tell us that that's about 0.927. That's in radians, which we're going to talk about in a few lessons. That equals 126.86 degrees approximately. So I'm just going to put 126.8. Now this question is definitely not meant to be that accurate. You can kind of eyeball it and see about what it is. But it does help to be a little bit close. So 126.8 is going to work for us. Okay, on this last question, they want you to calculate the sine of 126.8 using that angle and see if it equals the ratio we should get, which should be 4 divided by 5. So here we go. Sine of 126.8 equals about 0.8007. And if I kept going with that decimal, that would eventually equal 0.8. And 0.8 is the same thing as 4/5. So this is giving me the appropriate ratio based on my new definition. So is the calculated value using this definition the same as what the calculator tells us? Yes, it did work. So this new way of defining sine, where we, instead of calling it opposite and hypotenuse, we just call it y and r, is working out beautifully, and it will continue to work out perfectly for everything that we do.